Alright, so I'm going to be setting up an SN74LS595 shift register. So we already have it here and it's oriented correctly. You can see the little divot there. And using the datasheet, I'm going to start putting in the wires so that we can get this guy working. But before I do that, I'm going to set up the breadboard so that all my vertical rails have a positive and a negative, or a positive and a ground. In this video, we're going to put positive on the right and ground on the left. So this is my 5-volt power supply, and we'll put jumpers to continue those to the other rails. So positive can just be carried over here, and once more. We'll do negative or ground as well. Oops, that wire needs to be remade. I'll cut a new wire real quick. Should be using wire cutters, but I don't have them right now, and scissors seem to do the job, so just be using scissors. And I don't really need positive on the side, so I'm just going to use the ground. That's all I really need. And so what we're going to be doing is we're going to be setting up 3 buttons. One is going to be for the data line, which will either be high or low to represent ones and zeros. The shift line, which will shift that data into the stack or into the register. And the shift register line, which will take everything that's been shifted and turn on LEDs if they've been shifted on or off. And you'll see what I mean in a second. So first we got to get this guy all wired up. So if I remember correctly, positive voltage goes in this top right pin here. So pin number 16 is where positive voltage will go. So let's put a little wire here and give this guy, and while I build this I'm actually going to unplug the live wire so I don't accidentally do anything weird while I'm setting it up. So I'm going to take positive voltage and put it into this pin. And we might as well get all the LEDs set up because that's pretty easy. So the shorter leg of the LED always goes to ground, so that's why on this side I only really needed ground. And we need 8 LEDs because the shift register can handle 8. Alright, now these LEDs are going to be powered when these bits go on or off. Now there's 7 on this side and 1 on this side. Kind of a weird configuration, but it'll work. So the first one, if you refer to the data sheet, is over here. It's called A. So we'll run a wire from here over to the first one. Now I should be using resistors on these LEDs, but I don't have any right now, and we'll be able to live without it. It's bad practice, but we'll be able to do it. So B starts as pin number 0, so then it just goes down all the way to H, and H will be number 8. So although it does 8 LEDs, shift register, I like to call them with the alphabet. So B, Alright, the next pin on this side is going to be the data line, and I'm going to use a button to control whether that's high or low. To make it easier to see when the button is being pressed, I'm actually going to put LEDs in there as well. So the LEDs will go on when the button is pressed. I'm going to put positive to this side of the button so that this pin will go high when the button is pushed. Just make sure everything's working so the button lights the light when it's being pushed. Also this, right now everything was floating because this needs to be grounded. So the last pin number 8, just goes to ground. Much better. So this next pin is output enable, and it must always be low for the output to be enabled. So I'm just going to wire that straight to ground. So the next pin is the register clock pin, and when that's pushed, all the bits that have been shifted onto the shift register will be turned on, and they have latches so that they will stay on. So these LEDs will come on or off when this is set high. So the next thing I need to do is put another button. And I'm going to put these buttons out of order because it makes sense for programming it. But the next pin, I'm going to need a button, and that's what's going to turn on the LEDs or off when everything is shifted. So again, I'm going to use an LED so that we know when that button's being pushed. LED to ground on this side. Make the button get high. And then with this button's very sensitive, so it needs a capacitor to help it not be as noisy when it's being pushed, and that will help it so that it doesn't send multiple fires, and it reduces bounce. So ground this side with the capacitor, and it also needs a pull down resistor because the logic doesn't like it if it's not partially grounded. It wants a nice clean edge for the rise. And the next pin is the shift pin, and that's going to, every time the data line is high or low, when the shift pin goes high, it's going to take that data and push it onto the stack, the register. So I'm going to use a button for that as well. And these wires are switched. I feel like the data and the shift should be together, and then the latch should be last. So these wires are going to be reversed, but it makes more sense to do it this way. So the pin needs to go from high, or I should say the button should provide high to the pin. And actually, I think this button, it's more important to have the capacitor, so I'm going to move this one over here. And this will also need a pull down. So from ground, the switch will have a pull down so the logic is happy. And we'll put an LED there as well so that we know that we can see when this button is being pushed. Is that in right? Nope. The next one is the clear, and if I recall correctly, this should always be high, because it clears when it's low, so we want it to be permanently high. And this last pin is the output of the shift register, and what that means is after you push bits all the way through it, they're going to come out this pin, and what that would allow you to do is put multiple of these 74LS595s in a row, and this output pin would go to the input pin of this one, and you could keep stacking these forever if you need more bits in your project. And that makes these shift registers really awesome. So I'm just going to put an LED on there so we can see when it's outputting something. And since I do have a spare resistor, I might as well use it for this LED. And the button fell out. These buttons are terrible on breadboards. And I'm going to rearrange a little bit because these buttons are terrible and I need to find a spot where they can fit. So I had to make a few adjustments. These buttons are terrible. They keep popping off the breadboard, and when that happens it messes with the logic because the wires will no longer be properly grounded and they'll be floating, and so the signals it gets will be just noise. So we'll try to do it. Hopefully they'll stay in the breadboard. So this is the data pin, and I'm going to make the data pin high and push the shift pin once. When I push the latch, you'll see that the first light comes on. If I shift it again, it goes one over, and that's the basic pattern. You'll notice this light came on last, and the reason why that comes on is because that bit that we had shifted in is now coming out the other end of the shift register. And again, if you had multiple of these in a row, you could take this output and instead of putting it on an LED, you could put it to the input of another shift register, and that way you can stack them and get multiple bits. Each of these 74LS595s can do 8 bits at a time, but if you have 2 of them you can do 16, or if you had 4 you could do 32, and it just keeps going. So this time, make sure my buttons are seated well. A little bit better. So let's try this. On, off, on, off. On, off, on. And because this button's being a little annoying, it's doing multiple signals at once, but you can see the LEDs as they shift through, the bits shift through. 1, 2, 3, 4. Yeah, it's doing about 2 each time. You can see it's moving 2 LEDs each time I push it, so it's not the most reliable switch, but there's 2 on right there. Watch, I'll probably move 2. I moved 1 that time. 2, about 4. So what you can do with this is you can hook up these 3 buttons to your Arduino, and that will give you 8 outputs for only 3 digital outs. But if you stack these, like I said earlier, you could have 16 outputs, 32 outputs, as many outputs as you need. And so that's basically how you use a shift register.